Today we'll be looking at Newton's law of cooling for a liquid. We want to know the rate of heat loss at every instant. Okay, so that's the purpose of this experiment. So first of all, this is our setup. The calorimeter set with the stirrer, right? We have our thermometer and then the stand. So before we start, we need to take the initial temperature of the surrounding. We need to take the temperature of the surrounding, okay, before we start the experiment. So we are taking the room temperature, right? We take the temperature of the surrounding. So the thermometer, without anything, we have to record the temperature, okay? So we can record that one, example, like 30, 32, okay? Then we boil our water. So we boil our water in a kettle, okay? We boil our water in a kettle, okay? If you have a heater, you can also use a heater to boil water, okay? Once you boil the water, you pour it into this, like this. So you pour the hot water, the boiling hot water, into this, okay? Then we are supposed to put this, we put this in the other hole, okay? Then we start stirring, okay? Once we start stirring, we are supposed to start, you see, since the water is boiling, maybe the temperature is 90 degrees, okay? So what we do is, we wait till the water gets to 80 degrees, okay? That's supposed to be 50 degrees plus our room temperature. So that's 80 degrees. Then we start the stopwatch, right? Then we start the stopwatch. Then we start the stopwatch, okay? When we start the stopwatch, we record the temperature for every minute. So this is how our table will look like. We started at 80, okay? So 80 was 0.00. Then when this stopwatch gets to 1 minute, then we check the temperature. We check the temperature and then we record. Let's say we have 75. Then when it gets to 2 minutes, we check the corresponding temperature and then record. Let's say that one gives us 73. So that will be 2 minutes. Till we get to 35 degrees, okay? Till we get to 35 degrees. Till we get to 35 degrees. And then we complete this table. Now, when we finish with the setup, recording our values, when we finish with recording our values, we have to plot. We plot this against this, okay? So we plot this on the y-axis, and we plot the corresponding time on the x-axis. We are supposed to get a very beautiful curve like this, okay? And then the next thing we need to do is to find 5 slopes on the curve. So what we need to do first is to draw a tangent, okay? We take our ruler and draw a straight line on the point. We take 5 points on the curve. So we take our ruler and draw a tangent on this particular curve. Then on the tangent, we draw a slope. Now the tangent should be equal distance. I mean, if we take this point and we draw the tangent, right, the distance from here to here and then here to here of the tangent should be the same. So we draw 5 tangents in that order. We draw 5 tangents or slopes on the curve, right? After drawing the 5 slopes on the curve, then we calculate under calculation, we find the value of the slopes for all the 5 slopes. Now, when we find the value of all the 5 slopes, we do another table, okay? And then we put the value of the slopes that we have here, all the 5 slopes, because we will use this to plot a second graph. Now, to get this value, they are saying that this is the mean temperature of the surrounding. So after the experiment, we are also supposed to take this out like this, let it stand for some time, and then we take the temperature of the surrounding after the experiment. Let's say if we have 30 degrees, right? So this value is supposed to be the mean temperature of the surrounding. Okay, this is supposed to be the mean temperature of the surrounding. So we add this to this. So let's say we add that one, we get 32 plus 30. And then that one is supposed to give us 31 degrees as this. Then how to get this? We come back to the slopes, right? The point that we drew the tangent on, we trace it to the y-axis. So if let's say this is 90, let's say this is 70, right? We trace the point to the y-axis. So that's value that we get on the axis, we subtract it from our mean temperature, then we write it here, right? Then we come to the next one. This particular point that we use to draw the slope, the second slope, we trace that point to the y-axis. Let's say that one gives us 60, right? So we take 60 minus the mean temperature. So that will be this minus this. 60 minus the mean temperature should give us 29. Then we record that. Come to the third point. Trace that one to the axis. That value minus the mean temperature should give us till we finish for the 5 values, right? After that, we use this table that we drew, the table 2, to draw a second graph, right? Which that one we plot the slope against the temperature difference. Okay, so that one gives us a straight line. Now this straight line indicates that the rate of heat loss is proportional to the excess temperature at any instant. Okay, so that's Newton's law of cooling. So we are verifying. So for this particular experiment, we are not determining, we are verifying that this Newton's law of cooling, this particular law, that states that the rate of heat loss is proportional to the excess temperature at any instant, is very true, right? So that's the whole aim of this experiment. Thank you.